Good day, everyone. It's Steve, and today we'll do things in just a little bit of a different order. This here is the switch from my electric lawnmower. It controls the power to the lawnmower, and it's malfunctioning. So what I thought I'd do is I'd show you why this thing isn't working, a really nice way to fix it, and then we'll go back through the process of reassembling everything and getting the lawnmower back in its nice, tidy, functioning condition. A common symptom of how these switches fail is the power fluctuates while you're trying to use the lawnmower. It will waver between full power and somewhere between 0 and full power. So if that happens, I would highly recommend testing your switch first, which is really easy to do, and then cracking it open like I did to make sure that that's the actual problem. So let's take a look at what's inside. Now, I'm wearing gloves because you'll see in a moment that this thing is pretty filthy. So to open one of these things up, you need to get a flat screwdriver or small flat instrument that you can wedge underneath these pieces of metal that have been folded over to hold this top contact portion onto the button assembly. And you basically just work them up until you get clearance to open the compartment. Now, you're in for a surprise that when you open these things up, there are a bunch of springs that come shooting out and displacing all of these contacts that were in there. Closely inspect the portion of the switch that holds the contacts together. You'll notice that it's covered in all this black stuff, and that's precisely why this switch was no longer working. There was no way for electricity to flow between the contacts, even when pressed by the moving contacts that slide when the switch moves in and out. These contacts were both pretty dirty, and because I've been handling them, most of the black stuff has come off, but you can still see that there's lots of it still present. In fact, if I take this one, which is in pretty bad shape, and I rub it around on this white piece of paper, you'll notice, oh, look at that. There's quite a bit of it there, and that's precisely why I'm wearing these gloves. Now, what causes this black stuff to form on here is, I believe, electrical arcing. And arcing is when you get a really tiny air gap and a reasonably high voltage between the two conductors, and the electricity jumps across from contact to contact. And when that happens, you get a lot of heat, and stuff around the area that's being arced across tends to break down. So all this black stuff is basically just debris caused by that arcing and breakdown of the contacts and the material around it. So before we get into any further explanation on how this switch works, which is going to be important to know how to put it back together, I'm going to clean it up. I have some electrical contact cleaner that I'm going to use, which should make light work of this mess. So what I'll do is use my electrical contact cleaner to saturate those contacts that are pretty dirty, and then I will use a wire brush to just scrub everything down and get it as clean as possible. All the components have been cleaned, and I want to show you something interesting that I discovered. I'm going to try and hold this up in focus to the camera. All right. So the condition of this contact over here is extremely poor. It's very coarse, and if you compare that to these other contacts, they are very smooth. This one has some coarseness to it, but not as much as that one does. And if we look at one of these contacts, hold this up to the camera. This one here also has a lot of coarse marks over here and even more on the corner but not so much on the other contact. In fact, this one here almost has no markings on it at all, except for an imperfection on that side right there. So what I think has happened here is there was some imperfection in the contact, or perhaps it developed over time, and these particular leads at the bottom are the ones that carry power through it. That's been verified. I know that for a fact. You don't get power going through these other ones, in a matter of speaking. So when you have these little dimples in the contacts on both ends, you don't have a flat surface that mates with another flat surface. And those imperfections in there, or those air gaps that form, are a perfect recipe for arcing to occur at that scale and at the voltage at which is going through these contacts. So the arcing occurs over time, the contacts degrade even more, and the situation just compounds itself until either the contacts completely burn off, or you get all that soot that covers up the contacts and the thing just shuts down and stops working. Now, I should say at this point that I did verify that there was no continuity between the two leads that deal with power when the switch was in its closed position. That was what led me to believe that there was a problem with this switch. Let's take a quick look at a schematic of one of these switches and how they're supposed to work in conjunction with an electric lawnmower. Specifically, the interesting portion being these two leads on the switch which don't commute any power from your outlet to the lawnmower. This is a typical schematic for most electric lawnmowers that don't operate with a rechargeable battery. Thanks to Nick Vieira for putting this together on his website. The switch isolates an AC power source, and a bridge rectifier converts the AC power to DC for use in the electric motor. When the switch plunger is pressed, the power circuit closes, allowing power to flow into the motor as shown. While this power circuit is closed, a second circuit remains open. I'll call this second circuit the braking circuit, as it is responsible for slowing the spinning motor or applying the brakes to it, so to speak. When the switch plunger is released, the power circuit opens and the braking circuit closes. Now, since the motor contains a coil, it will have built up a magnetic field while operating, just like an electromagnet. When the motor's power is cut off, the magnetic field collapses and induces a new current back into the coil. The new current has an opposite polarity to the one that spun the motor to begin with, so it tries to spin the motor in the opposite direction from which it's currently spinning, thus bringing the rotation to a quick halt. So now that we know how the switch works, putting this back together is pretty straightforward. We need to have a contact that's in the off position on the top, and when the switch is pressed closed, we need to have the contact that transfers the power or puts the thing in the on position on the bottom. So what I'm going to do is I'm going to actually use the one that's damaged on the contact for the braking leads, and I'm going to use the one that's in good condition, which is this one over here on the lower part, which is for the contacts that commute power through the lawnmower motor. So these springs go into these holes, like so. And then the contacts, this is the good one, so I'm going to put this in the bottom. One end of the contact goes into the depression, that little rectangular depression on the corner, like that. And the other end will get pressed down when the whole switch assembly closes. So we'll put the other contact, I'm going to install it in this way so that the damaged end is on that side. Of course, this is all going to fall apart because of these springs. I think Big Clive said in one of his videos that springs are the things that prevent you from fixing anything, because they like to expand and explode and shoot things off in all directions when you try to take them apart or even put things back together again. It kind of reminds me of one of those cans of snakes, those gag toys that say peanuts or something on the outside, and when you open up the can, it's just a bunch of spring-loaded snake-like things that shoot out into the person's face. I kind of miss those toys. All right, Snake toys aside, the next step is to orient this in the proper direction, and it actually only goes on one way. It's probably a good idea to figure out what way that is before you try to put this back on, and we install it like so. Get that in here. And then press the whole thing down and hope it doesn't blow up. I screwed something up. Perfect. All right, that's staying put, as we can see, but it's not very secure. It's about to pop open at any time, so I'm going to go around and just secure each of these 5 levers or little clips to hold the top in place, and then we'll give it a test. All right, let's test the switch with the multimeter. Put it in continuity mode. Confirm. All right, and if we remember from the schematic, the 2 pins at the top of the switch, when in this orientation, they are the breaking pins. And so when the switch is in the open position, open with respect to power, you'll have no power coming through on the bottom leads, but the breaking leads will be closed. So let's test both of those out. The breaking lead should be closed. And they are. And the power lead should be open. And they are. Okay, now we'll test with the plunger closed and see that those 2 readings will be inverted. Okay, first the power leads. Okay, and that's good. Release. And then we'll test the top one. And bear with me while this thing makes a bit of noise. And that sounds good. I've released it. Press it again. And release. Okay. That's enough testing. I'm pretty convinced that this is working. And just for reference, this is how you would have tested the switch to begin with if you didn't know that the arcing and the soot inside the switch was the problem. So now let's go off to the lawnmower and install the switch into the control handle. So here's the control housing, the wiring harness, and the switch that we need to put back together again. Now, your housing might look a little different. It probably has a pair of AC power leads sticking out from this area, and those leads likely have some wires that lead to somewhere around here, and those wires probably have some of these spade connectors on the end of them. Now, I don't have that because I had to modify my housing to use a proper AC plug because I had some arcing and melting issues that basically destroyed this whole area and the plug that was in there. I'll show the results of that in a moment. But now what we need to do is we need to basically connect this switch back up and place the switch back into the harness or the housing. So this switch goes right here. And if you see how this goes in, once you push it in place, it's a pretty snug fit, like so. Then this lever actuates the plunger on the switch. Okay, so it's best to have it wired up before you put it in here because it's a pretty tight fit. So we'll do that first. And we have to remember which ones of these 4 leads are the power leads. And they are on this switch, this one, and this one. When I was working on the bench, I had it oriented in this way. And the bottom 2 leads were the power leads, and the top 2 were the motor's braking leads. So let's make sure we put the correct color on the correct leads, and we won't have a surprise when we plug in the lawnmower. So my power leads are the black ones. They connect like so. Let's see. This one here. The black. Okay. And we now have to connect the braking leads. I think I'll put the red one in first. And then the white one goes here. Alright. Do a quick check. Black and black on one end, red and white on the other end. They're both on the correct end. These nuts look, or these morettes, are pretty snug. Okay, so now let's put this into the case. That's pretty good. I'll route the cables accordingly. Okay, that's pretty good for now. So I can't just put the housing cover back onto this, because when you put the housing cover back on, it actually connects this part to the handle that pushes the lawnmower around. So you have to first put the open part of the housing onto the handle, then the cover on top of the handle and the other part, and then screw everything together. So we'll do that right now. Alright, time for a test. If this works, I can finish mowing my lawn. Now that my lawnmower is working again, let's revisit the control housing and the modification I alluded to earlier. I refer back to Nick Vieira's website for further information, as he experienced and documented the same problem I'm about to discuss, as well as a clever switch replacement. This photo shows what happened. Either the AC power lead in the housing wasn't rated for some current that passed through it, or it didn't make a good connection with the extension cable's plug and caused some arcing. In either case, this created a lot of heat and melted part of the housing and the cable's plug. I fixed this by replacing both AC power leads with a new AC power cable, making sure that the cable's gauge is the same as the existing wire that connects the switch to the motor. It doesn't make sense to use a larger gauge since it won't likely be rated for the current that's drawn by the motor. Next, I removed as much debris as possible from the housing, then drilled a hole in the housing to route my new power cable. The new power cable was joined to the existing power wires with morettes, which some people also call wire nuts, and everything was closed up and put back together again. Now, this may or may not be acceptable for electrical code, so please consult with a certified electrician if you have any doubts about performing this implementation. Finally, I could not salvage the plug from the extension cable, so I cut it off and replaced it with a plug that was marketed as heavy duty. If you're not familiar with how to connect the plug, you'll need a multimeter to verify continuity from the leads on the male end of the cable to the inlets on the new plug that's installed on the other end of the cable. And here's a photo showing the end result. So that wraps things up for this video, and as usual, I hope you find this information useful. Please feel free to leave your comments and questions below, as well as suggestions for future topics.